Now we study second important method, Gauss-Seidel method. In this method we take one example, solve the system of equation using Gauss-Seidel iterative method up to 2 iterations. And the given 3 equations are 10x plus y plus z equals to 12 2x plus 10y plus z equals to 13, x plus y plus 5z equals to 7. So these are 3 equations. So we have to solve this system using Gauss-Seidel method. Now we solve it. The given equations are, write down first 3 equations. After writing these 3 equations, we can write it in the form of xyz as, consider the first equation, that is this equation, ten x plus y plus z equals to 12. Write this equation in the form of x, that is 10x equal to 12 minus y minus z. This implies that x equals to 1 by 10 in bracket 12 minus y minus z. That's it, equation number 1. In this manner, second equation can be written in the form of y, that is y equals to 1 by 10 in bracket 13 minus 2x minus z. Similarly, we can write third equation in the form of z, that is z equals to 1 by 5 in bracket 7 minus 6 minus y, and given number to these 3 equations as 1, 2, 3. Now, to solve this equation, consider or take value of y and z equals to 0. Y and z equals to 0. And put this value of y and z in equation number 1. And therefore we get first value of x, that is x1. First value of x, that is x1. And when we putting the value of y equal to 0 and z equal to 0 in equation number 1, then we get value of x, that is first value. Therefore we get x1 equals to 1.2. So this is first value we can obtain by putting y equal to 0 and z equals to 0. Now put this value or take this value x1 equals to 1.2 as x. x1 equals to 1.2 as x. Okay, and z equals to 0 as it is. Now put this value of x1 as x and z equals to 0 in equation number 2. Then we get the value of y, that is first value of y. Therefore we get y1 equal to 1.06. Now we obtain two values, x1 and y1. Consider x1 as x, that is x equals to 1.2, x equals to 1.2, this one, and y equals to 1.06. Now put this value of x and y in equation number 3. Then after we get the z1 value, that is z1, that is first value of z, and that is 0.948. So in this manner, by using first values y equal to 0 and z equal to 0, we obtain 3 values x, y, z, that is x1 equal to 1.2, y1 equal to 1.6, 1.06, and z1 equal to 0.948. In this way, we can obtain the second value of each x, y and z, that is x2, y2, z2. How? So, now we have three values x1, y1, z1. Consider y1 is equal to y and z1 is equal to z. Therefore, we get y1 this value 1.06 and z1 0.948. Now consider as that value y1 and z1 in equation number 1. Now put this value in equation number 1. Therefore, we get second value of x, that is x2, and the value of x2 is, we obtain the value of x2 as this, x2 equals to 0.9992. So in this manner we obtain x2 by using y1 and z1. Now take this value of x2 as x. Take this value of x2 as x, that is 0.9992, and z1, the value of z1 is 0.948. Putting these values in equation number 2, we get the second value of y, that is y2 equal to 1.0053, and after that putting the value of x2 as x and y2 as y in equation number 3, then we get the second value of z, that is z2, that is 0.999. So in this way we obtain second value of all variable x, y and z. So in this manner, up to 2 iteration, we find all this value of x, y and z. And when we observe all these three values of x, y, z, that is x2, y2 and z2, observe that the value of x2 0.9992, which is nearly equals to 1, value of y2 which is also 1.0053, nearly equals to 1, and value of z2, that is value of z2, that is 0.999, which is also nearly equals to 1. So in this manner finally we obtain the approximate value of x, y, z as x equals to 1, y equals to 1 and z equals to 0. That is our final value. Now we study last method, Jacobi method, in the next video.